Hi ladies, in this video we're going to go through 3 questions in 5E that are quite tricky. So if you are having trouble with these questions, it might be a good idea to put these down into your bound reference for future reference. That's what the purpose of the bound reference is. Okay, let's get started. So I've taken these questions straight from the textbook. So we're doing questions 8, 9 and 10. So if you're okay with question 8, just fast forward. All right, question 8. A student factorizes x squared minus 2x minus 24 by completing the square. So first of all, show the students working out. So we're going to complete the square first of all. So I'm going to write x squared minus 2x minus 24. So remember, when we're completing the square, we identify our value of b, which in this case is -2. So b is always the coefficient of x. And then we rewrite our equation, or sorry, our expression. Okay, so the first 2 terms stay, and then we add on -b over 2 squared, and then actually just still b. I'm going to get rid of this b. So instead of b, I'm going to write -2. I don't know why I wrote b. I haven't put the negative sign in, and then -2 on 2 squared. So I haven't really changed anything. Okay, so remember, when we're completing the square, hopefully if you got to this stage, you understand what we're doing. And then the -24 on the end. So let's scroll up. So I'm going to factorize these 3 terms first. So if you want to, you can rewrite it. And I'm going to keep this value inside the brackets just as -1. I'm not going to square it, and I'll explain why in a sec, but this one I will. So -2 on 2 is -1. Then when we square it, we get +1 minus 25. I don't know whether you can hear, but I live right near an airport and there's helicopters going all afternoon. Okay, so when I factorize this, it's just going to, I'm going to use this number here in the brackets, so -1. So it's x minus 1 squared. And then I've got minus 26. Okay, so then I can complete the square. So I'm going to identify, do the difference of perfect squares. So this is the a, and this is your b. So a is equal to x minus 1, and b is equal to the square root of 26. Okay, so got x minus 1. I knew I made a mistake. It's not 26, you silly girl. Okay, let me just rub that out. I knew it should have been 25. That's why I wrote 25 up there. Sorry. Hopefully you're following along and go, oh, she's made a mistake again. There we go. That should be 25. I don't know whether you could tell. When I know I've made a mistake, I pause and I'm trying to think as I talk. There we go. So the square root of 25 is 5. Nice. There we go. So we're doing a plus b, a minus b. So a is x minus 1 plus 5, which is b, and then x minus 1 minus 5. So we're just going to bring those values together. So x minus 1 plus 5 is x plus 4. And then, sorry, distracted by an email coming through, and then x minus 6. Now the second part of the question asks, now that you've seen the answer, what would you suggest is a better way to factorize this expression? So you can use it to factorize it by completing the square, but you can also see that you can easily just find 2 numbers when multiplied gives you -24, and when added give you -2, and there's our numbers there, 4 and -6. So you can complete the square, but remember that in maths, sometimes most of the time, there's more than one way to do things. So you could have factorized it the other way. And I'm just going to close my emails. Okay. Question 9, explain why x squared plus 9 cannot be factorized using real numbers. So basically, this is as far as we can go. We can't factorize it any further, and we can't factorize it using the difference of perfect squares, because the difference of perfect squares, remember the word difference, it is there because that means we subtract. So if I was saying what's the difference between 10 and 5, 5 is, well, I shouldn't use two numbers the same. 10 and 2, the difference between those two numbers is 8. So the word difference means we subtract. So it has to be a squared minus b squared. So we can only factorize it if there's a minus sign there. So if we look at part B, the only ones that can be factorized are if they're separated by a minus sign. So first one can, second one can, this one can't. So x squared plus 6 can't be factorized. X squared plus 11, nope. V, part 5 can't be factorized. There's no minus there. There's a minus here, so good. We can do that. We can factorize that. We can factorize this one, and we can't factorize the last one. So remember, if we're doing the difference of perfect squares, there needs to be a minus sign, because basically, if we were to factorize it, we would need to, if it was a positive or plus sign, we would need to take the square root of a negative number, which we can't do. We won't get a real, that's why I keep saying real numbers, because if you go on to do specialist maths, you'll understand the concept of imaginary numbers, and that's when you can take the square root of a negative number. Okay, let's move on to C. Just did B. For what values of m can the following be factorized? Okay, so once I do the first one, you probably understand how to do the other two. So let's just do the first one. I'm sorry about my bad writing. So remember when let's just ignore this m for now. So we're going to factorize using completing the square. So I'm going to identify my value of b, the coefficient of x, which is 4. So I write my first two terms, and then I add b on 2 and square it. Then I got to subtract that. And then I'm going to add m on the end. So keep going. So you've probably done this a lot now by the time you got to question 9C. We've got 2. I'm going to leave that in brackets so we know how to factorize that. And then we've got -2 squared, so it's going to be -4 plus m. Okay, so factorizing this gives me x plus 2 squared minus 4 plus m. Now, remember I said you can only factorize using the difference of perfect squares, or you can only factorize by using difference of perfect squares when there is a negative here. So there's a negative at the moment, but if this m changed, it could change and make it a positive. So basically this whole thing needs to be equal to or greater than 0. So -4 plus m has to be greater than or equal to 0. Sorry, did it around the wrong way. Less than or equal to 0. Okay, so for it to remain a negative. Okay, so I'm going to just move that 4 over. So m has to be less than or equal to 4. So if m was 4, it makes this part 0. So -4 plus 4 gives you 0. If m was, so remember it has to be less than -3, so -4, so if it was 3, it would be -4 plus 3, which still gives you a negative number, -1. If m was 0, okay, so 0 is less than 4, -4 plus 0, okay, you still got that negative there. So m can be anything less than 4. Right, so I'll just go through another question, because I sometimes think when I explain things, sometimes doing it a second time helps sink it in. Okay, so I can't remember if it was a plus or a -6, sorry, -6. -6x plus m. So we're going to identify b first. So b is -6. So I'm going to complete the square. So the first two terms stay the same. Then I add b on 2. So b is -6, square it, then subtract it. Now, that is a 6, not a b. And then I'm going to plus m. All right, so let's just tidy things up a bit. I'm going to just skip the step and say, all right, that's x minus 3 squared. And then I'm going to have -9 plus m. Remember, if we're going to do the difference of perfect squares, this has to stay a negative. Okay, so a negative number is less than 0. So -9 plus m has to be less than or equal to 0. Okay, so it has to be either 0, so it disappears. So if m was 9, it would go away. But it then has to also be negative to do the difference of perfect squares. So it has to be less than or equal to 0. So I'm just solving that. So bring that 9 over to the right-hand side as positive. So m has to be less than or equal to 9. So if m was 9, we're left with x minus 3 squared, okay, which that's factorized. If m was, so a number less than 9, we can say it was, I don't know, 2. So we're going to have -9 plus 2. Then we just simplify that. So it's still a negative. Okay, so whatever number m is, as long as it's below 9 or equal to 9, you can do the difference of perfect squares. All right, I'm not going to do the last one because same working out. Now this one here, I'm not going to do a to l, but I'm just going to explain what it's done in this, the working out here. All right, so we've got a non-monic. Remember, non-monic just means the coefficient of x squared is something other than 1. So in this case, it's 2. So we've started off by taking 2 as a common factor. Now you might be sitting there thinking, but it's not a common factor because 2 is not a factor of 5. But you can turn it into a fraction and factorize it like that. Okay, so 2, if we were to expand this, 2 times x squared is 2x squared. 2 times -5 on 2 is -5. 2 times a half is 1. Okay, so we're just taking out that 2. Then in the second line, what it's doing is completing the square. So this center part, okay, so b is 5 on 2, and then you divide it by 2. Okay, so that's what that note part is. So we're basically doing 5 on 2 is 5 divided by 4 squared. And then just completing the square, tidying things up a little bit, and that's what you're left with, that factorized answer. Now there is an easier way to do this. When I saw this, I thought, why wouldn't you just use the quadratic formula? So the quadratic formula we're doing towards the end of chapter 5, and that's what you would do to answer all these ones. But I might just do one with you so you can see it, and I might not do A because that's always the easiest one. So let's do J. So 3x squared plus 4x minus 5. Okay, so the coefficient of x squared has been taken out as a common factor. Okay, so if I take 3 times x squared is 3x squared, 3 times 4 on 3 is 4, 3 times 5 on 3 is 5. All right, so the 3 stays out the front, and now I'm going to complete the square. So your first 2 terms stay the same. Then if we identify b over here, which is 4 on 3, now remember the next thing I'm going to do is b on 2 squared. Yeah, so when we complete the square, we do b on 2 squared. So effectively, we're going to be doing 4 on 3. So that's our value of b, yeah? And this is the same as dividing by 2, divided by 2. Now, when I divide a fraction, I multiply it by its reciprocal. So then it's going to be 4 times 1, 3 times 2. So now in my bracket, I got 4 on 6. Okay, so you see that? I probably should simplify that. As soon as I wrote that, I thought I should change that to 2 on 3, which I might still do. Okay, so I'm just simplifying that fraction. So 4 on 6 is the same as 2 on 3. I think I said 3 on 2 before, sorry. There we go. 2 on 3 squared minus 2 on 3 squared. And then what are we left with? Minus 5 on 3. It's going to go back to the original question. Okay, so that middle part is quite tricky. So if you wanted to do it to the side like I did, so you don't get mixed up. All right, so let's keep going. So we can factorize these first 3 terms. So it's just going to be x plus whatever is in that bracket. So it's 2 on 3 squared. Now, I'm going to put that in its own bracket because 3 is multiplying everything, whereas we're only squaring these 2 terms. All right, then I've got 2 on 3 squared, so I'm going to square my numerator, which is 4, and square my denominator. So it's going to be 9, and then minus 5 on 3. And let's close the bracket. All right, let's tidy things up a little bit. Okay, so x plus 2 on 3 squared. Now, if we're subtracting or dealing or adding fractions, have the same denominator. So I'm just going to do it here because I don't want to write another line. So 5 on 3, I'm going to make them both on 9. So I multiplied that by 3, so I do the same with this one. So I've got negative 4 minus 15, so negative 19 on 9. And now I've got the difference of perfect squares. So ignore that 3. We're just going to deal with these 2 terms in the middle. So when we're doing the difference of perfect squares, this is my a, and my b is coming from there. So that's b squared, sorry. That's a squared. So your a is x plus 2 on 3, and your b is the square root of 19 over the square root of 9. So it's going to be the square root of 19 over 3. Okay, so now I've still got the difference of perfect squares, a plus b, a minus b. So let's write out a, x plus 2 on 3 plus root 19 on 3. And then x minus, plus 2 on 3 minus root 19 on 3. And if you wanted to, you can put it all over the same denominator. So when we do the quadratic formula, you will see, it looks exactly the same, your final answer. But quadratic formula, my friends, is so much user-friendly. And do you know what I forgot to do? I've got the 3. So we'll just put the 3 there. And then we've got x plus 2 minus root 19 all over 3. So perhaps have another go at doing one of them, but you don't have to do all of them because you'll probably use a quadratic formula from, in a few weeks you'll be exposed to it, but you'll always solve these using the quadratic formula. All right, bye.